Hello everyone, I will present our paper, Theoretical Neural Architecture Search for Travel Time Estimation. Let's see the outline of my presentation. First, let's see the challenging section. There are three main challenges as follows. You can see here. In our paper, we modeled the road network as the Duan graph, as shown in this figure. We model the intersection and the links as the node-wise graph and edge-wise graph respectively. Second, let's see the second section, methodologies. First, let's see the framework of our model, Auto-STDGCN. At the top of our model is the embedding layer, whose function is to map the original features of links and intersection to high-dimensional space. After the embedding layer is the most important part, spatial temporal learning layer. In this layer, we design the external and internal architecture search space. The internal structure is to search independent spatial temporal architectures of node-wise and edge-wise graph. The external structure is to search the interaction pattern between the Duan graphs. We adopt the gradient-based model DARTS for neutral architecture search, as shown in these equations. The internal search space contains spatial graph convolution, temporal convolution, identity, and zero. The external space includes node-wise operation, edge-wise operation, identity, and zero. Next, let's see the detailed structure in node-wise operation and edge-wise operation. In these two operations, we adopt the incident metric to achieve the transformation between the representation of edge-wise and node-wise graph. The computation process are shown in these equations. Multitask learning layer is the last part of our model. In this part, we adopt the GRU network as the decoder to model the trajectory sequence. In this manner, we can obtain the link time estimation by every step. Meanwhile, we can aggregate the representation from GRU cells to obtain the estimation of the enter path. The computation process are shown in this equation, GRU-based decoder and the loss function. Let's see the experimental results. From the overall performance table and the evaluation study table, our model achieved the optimal performance among the baselines and the evaluation variants. Finally, we summarize our main contribution in these papers as follows. You can see here. Then improve the efficiencies and the deployment of our models are two important directions in our future works. Thank you. That's all of my presentation.